we had a last minute slight change in the schedule to 1:30. And the reason for that was that Steven Chown got called to an urgent meeting with DFAT, which he had no choice but to say yes to. And I'm acutely aware that that was at 1 o'clock and it was scheduled to finish at 1:30. So I'm aware that that may go over time slightly.
No, I'm here, Perrin.
You're there, good, all right. Good, excellent. So we can make a start. Thanks, Stephen. All right, so I just wanted to say a few words. So first of all, thank you very much for coming to the first of this climate change seminar series. I'll just start by noting that Monash is on the lands of the Bunurong people, and I wish to acknowledge them as the traditional owners. I'd also like to pay my respects to their elders, past, present, and Aboriginal elders of the communities who may be here today. No doubt we're all coming from different traditional lands. So I think this seminar series is very timely. Every week we seem to be seeing the latest record effects of climate change, whether it be record high temperatures in California, fires, rain in Greenland, and also the release of the IPCC report has really brought the importance of this issue into great focus. The initial motivation for this is, there's a bit of background noise, if you could mute yourself, please. Thank you. The motivation for this series came from a conversation I had with Lincoln Turner, and we were lamenting the fact that some of the dialogue around climate change in the university was being mediated by a fossil gas company. And he said, well, maybe we should do our own climate conversation. And of course, when I thought about the faculty, we actually have some of the best international leaders in the field, spanning biosphere impacts, human impacts, the atmospheric and hydrological sciences, as well as energy technology solutions. So the aim of this series is really to showcase some of the amazing research leaders in these fields, and hopefully to make some connections across the faculty and the university more broadly. Next year, we plan to continue this series and open it up and invite participants to contribute from across the university and also outside. As scientists, we often tend to stick to our knitting, but sometimes we need to stand up and help drive change. And I think this is one of those times. Think about how you can do this either through political action or uptake of new technologies and approaches. Our first speaker is really timely. He's really someone who connects scientific evidence to wider policy and practice. As a PhD student, Professor Steven Chown cut his teeth in his area of research in sub-Antarctic islands. He noticed that the supply of fresh vegetables to the islands contained potentially invasive species, and he managed through reasoning to articulate that this shipment should actually be destroyed. And I think he might have made himself a bit unpopular with some of the people. Steven has got quite an impressive, or an extremely impressive record of achievement. His scientific stats are quite amazing, 35,000 citations and an H-index of 96. But beyond that, Steven has made a contribution recognised by his peers, as indicated by his election to the Australian Academy of Science, the American Academy of Arts and Sciences. He was recently awarded the medal of the 30th anniversary of the Madrid Protocol by the French government. In addition to that, he's shown quite amazing leadership. As the head of School of Biological Sciences, he led quite significant change there to put it in a position of extreme strength now. He's also just led the securing Antarctica's environmental future bid, which was quite a coup because the University of Tasmania has traditionally dominated that area of funding, and Steven managed to wrest a significant amount of money away from that. So without any further ado, I'd like to hand it over to Steven now to give us his presentation on why Antarctica tomorrow should be your concern today. Thank you very much, Steven, for agreeing to be our first speaker.
Great. Thank you, Perrin, for that lovely introduction. And thank you also for arranging this series of talks. like yourself and Lincoln, I think we don't talk to each other enough in universities. We spend quite a lot of time walking past each other in the corridors and not enough time having a conversation with each other. I'm also mindful that you had as the basis of this, the fact that we would be able to talk with each other in person. Unfortunately, we find ourselves in a slightly different situation just at the moment. And I'm aware that everybody is pretty zoomed out or teamsed out or whatever you'd like to call it. So thanks also to the audience that actually has shown up for yet another Zoom presentation. What I'd like to talk with you today is about Antarctica, and I hope you can see the screen share. It should have come up for all of you. And the reason I want to talk to you about Antarctica is A, because I've worked there a long time, but B, because it's so important to our future. So hence the title, why Antarctica's tomorrow should be your concern today. But in fact, it's also Antarctica's past and present that should be of concern to us. So for those of you who don't know the continent and its surrounding Southern Ocean very well, this is a satellite image view. And there are a few things that are important. The first is to note that it is an isolated continent, the most isolated one. It's also the highest on average. It's the driest on average, although there's, of course, a lot of frozen water. Frozen water is not available for life. It's the windiest continent, too. And it has this remarkable change on an annual basis where the sea ice grows around the continent in the winter, as you can see here, and then declines again in the summer. So it has this massive change in the cryosphere from season to season. When most people think about Antarctica, they actually mostly see it as this, I think, is the white blob at the bottom of the planet. If you're really lucky, then people will think about a few other things. They usually start off thinking about penguins, remembering vaguely that penguins are really what makes Antarctica. If they think a bit more, then they might remember that there's also quite a lot of seals. Usually leopard seals come to mind most frequently because of their rather fearsome reputation. And again, if they think a little harder, then they'll remember that the whales that one sees around the world actually spend quite a lot of time in Antarctica because of the resources. So generally, that's the perspective that one has almost immediately. And if pushed a little harder, especially those who have some experience or have watched enough Attenborough or other natural history documentaries, they'll remember that just a small part of Antarctica, the peninsula, has flowering plants. This is a grass that you can see in the foreground here called Deschampsia antarctica. And that quite a few parts of Antarctica have mosses and lichens, but virtually nothing else that makes the continent recognizable. The final thought that tends to come up in people's minds is that it's a continent that is covered in ice, but in fact, it does have some ice-free areas. This is the McMurdo dry valleys of the Ross Sea area, and the scale is just extraordinary. Looking across to the Beacon sandstones and other parts of the geology of this area. One tends then to think of the fact that Antarctica is entirely isolated and free from human disturbance. And in fact, most of the continent by our standards used for elsewhere in the world can be considered a wilderness. But we shouldn't for a moment think that we haven't had some influence locally on the continent. And this local influence is not going to be part of the talk I'm going to give you today much, but I do want to just dwell on it very briefly and show you an image from a previous PhD student of mine who's now graduated, which is an image of 200 years worth of human activity. And for those of you who know the continent well, you might think that the red dots are all markers of ice-free areas, but they aren't. They're in fact historical human activity records, about 2.7 million of them for the last 200 years that essentially Western European science has been exploring the continent, and all the tracks you can see across the continent here are in fact research tracks and exploration tracks. And the purple areas are the areas that we think might actually be the last areas of the continent where humans haven't been, mindful of the fact that we have no data from the Soviet era here, and the Russians were really very good at exploring different parts of Antarctica. But the idea that it's a completely untouched continent is not quite accurate anymore. And indeed, it's this reciprocal influence between ourselves and the continent ourselves that is the subject of my presentation mostly this afternoon. So when we think of our world, we often tend to think of Antarctica as this isolated continent that has no influence on us. And we think about all the things that we currently have to do now, either to secure future in cities of various kinds, or of course to secure, if you're in the conservation field, the species with which we share the planet. And we know that there's difficulties coming for us, and that we have some options to try to reduce the difficulties that are coming for us. So we know we're dealing with warming, we know we're dealing with disease, we're dealing with pollution, there's deforestation or habitat change, and we've set ourselves a series of goals to try to deal with the problems that are coming for us. But we don't tend to think of these goals or the difficulties we might encounter as society or for conservation in terms of the Antarctic. The Antarctic is very often far from our minds. And any Antarctic scientist that you encounter will tell you that that contention is rather incorrect, that we should be thinking almost on a daily basis about the fact that Antarctica is of massive importance to us. And I'll start by just giving a bit of a shout out to Julie Arblaster, who will be speaking in this series too. I'm not going to deal with the relationship between climate of the Antarctic and Australia, but to point you in the direction of the fact that some work that Julie and her colleagues have been doing, as well as others, demonstrate that there's a very strong link, and a link worth paying attention to. So what happens with Antarctica's weather doesn't stay in Antarctica. In fact, it comes all the way up to Australia to influence us, and vice versa. And this is important in the context of the fact that we're seeing a rather dramatic increase in the number of extreme heat events. And this data presented here is from the annual report produced by the Bureau of Meteorology. So I'm not going to talk any more about that, because the speciality is really that of Julie's and other colleagues at Monash, including folks such who are in the School of Earth, Atmosphere and Environment, like Christian Jacobs. What I rather want to do is spend some time on one of the most obvious features of the Antarctic. Even if you're a biologist, this is the feature that strikes you immediately, is that it has a lot of ice. So for those of you who don't know the amount, it's enough to raise global sea level if it all melted by about 58 meters. I don't think it's all going to melt especially soon, but we'll come to that just in a moment. So thinking about this part of the Antarctic, the cryosphere, is extremely important. And in part, that's what the research in securing Antarctica's environmental future is all about. And the information I'm going to present to you today partly comes from research we've done, but mostly comes from these three reports that I've set out here that I would say are essential reading. So if you're looking at this presentation and you haven't had a read of these, just the summary for policymakers will do if you're time constrained. The documents themselves are super interesting, but very long. Several thousand pages in some instances. These documents are extremely important to understand what the influence of Antarctica is on the globe, and what the influence of the globe is on Antarctica. And I'm going to concentrate for the next few slides in the most recent report of the Intergovernmental Panel on Climate Change, and that's the Assessment Report 6 and the report from Working Group 1 in particular. So the summary for policymakers in section B 5.3 made the following statements, which should immediately spring out to you as statements of concern. If we follow a very low greenhouse gas emission scenario, and I'll get to these in a moment, then we might expect anything up to 0.5 meter of sea level rise by 2100. Under a low greenhouse gas emission scenario, it's up to 62 centimeters. Under an intermediate greenhouse gas emission scenario, it's 0.76 meters or 76 centimeters, and under very high scenarios, it's up to 1 meter. 1 meter of sea level rise or 76 centimeters of sea level rise is a lot of sea level rise. It's, of course, sea level rise that is not simply a bathtub. The sea level doesn't rise simultaneously across the planet in the same way. It depends quite a lot on who loses the ice first, the ice mass first. If it's Greenland, the water ends up coming to us. And if it's the West Antarctic ice sheet, the water ends up going north. And in addition, different parts of Australia, for example, have different sensitivities to sea level rise. And that's still excluding storm surges and all sorts of other things that accompany them. But this is an extremely concerning statement. And remember that the IPCC is a politically agreed document in the end. All the countries have to sign up to it. And this is generally thought to be quite conservative. So where all of this water comes from is in fact from the world's glaciers. Largely, there's of course some thermal expansion, but I won't get into that. But a lot of sea level rise is coming from ice mass loss across the globe. This is work just recently published in Nature by Huguenet and colleagues, showing that every glacial setting you can think about has got a minus sign more or less attached to it. There are a few that haven't, but the losses are really quite substantial. So we know that we can expect this to be ongoing, and we can expect the ongoing mass loss to be higher under higher CO2 concentrations and therefore elevated temperatures. And of course, what's critical about this, in my mind anyway, since this is glaciology and the cryosphere is not my field, but it's one I follow very closely, is that when you look at particular studies of Antarctica, then the trajectory is one not only of a decline overall, especially from West Antarctica and the Antarctic Peninsula, but that decline itself is accelerating. This is from the MB team led by Andy Shepherd, and there's of course been a bit more recent work. This I think was published in 2018. Antarctica has this huge contribution to make to changing sea levels, and of course therefore a massive impact on ourselves, especially coastal settings and the infrastructure that's associated with them. And if we look at a map, this is work by Ben Smith and colleagues that came out last year in Science, you can see that the red areas which have to do with mass balance, this is mass loss, are now distributed right across the continent itself. Of course, there are areas with mass gain, but you can see that there's mass loss from the East Antarctic, from West Antarctica, from the peninsula itself, and the expectation is that this will continue. So Antarctica is going to play this enormous role in what happens tomorrow and the day after and continuing for quite some time. And for that reason, Antarctica really has to be in our minds all the time. What is it that we're doing about this change? Do we understand it? And that understanding, I think, is really critical. So when we think about the pathway that we're on, we have to ask ourselves, you know, which of those pathways do we think we're really on? And you'll have seen some suggestions of the previous representative concentration pathways of where we sit. But for me, the International Energy Agency is always the group to have a look at. And their view is that, and this was their 2020 report, this is just the summary, there isn't a 21 report out yet. And their indications were that CO2 emissions in the model that they use edge above 2019 levels on their way to 36 gigatons in 2030. And if you think that what we really should be doing, according to the IPCC's previous reports, is getting to net zero by preferably the 2040s to 2050 at the very latest, they're forecasting that in 2030 we'll be at 36 gigatons. So if you look at the new scenarios out of IPCC AR6, you'll see that in effect, if we're at 36 gigatons by 2030, then we're sitting somewhere between 126, SSP 126 or SSP 245, and that would indicate to us that we are looking at global temperature increases of 2.8 degrees or so total from a combination of CO2 and other greenhouse gas emissions. So that's the suggestion, and of course what that means to us is that we can expect out of the Antarctic, if we go back to our IPCC AR6 report, we might expect that we're going to see not 28 to 55 centimeters of sea level rise, but in fact we can expect 76 centimeters of sea level rise. You might think that of course this is all settled, but the images I've shown you just previously of the way ice sheets change really have a lot of uncertainty in them. So there are people at Monash that work on this uncertainty. Andrew McIntosh and Felicity McCormack, for example, are doing some work in this area where it's pretty clear that we don't really know enough yet about how ice sheets will respond to know whether we're going to stick with a scenario that looks something like this. And importantly, in section B 5.3, if you read a little further on, you'll see that they have this statement that global mean sea level rise above the likely range, in other words, what you see above there, indeed approaching 2 meters by 2100, cannot be ruled out because of deep uncertainty in ice sheet processes, and in particular, ice sheet process in the Antarctic. Now, I'm often asked by people who say 2 meters is not a huge amount of sea level rise. And even if you want to take a straightforward bathtub scenario, then I always suggest to people that the following is useful: is take your house and mark 76 centimeters on the wall. And then once you've marked 76 centimeters on the wall, have a think about what it would be like wandering around in your house with 76 centimeters of water in it, and then mark 2 meters and have a think about that. Now, of course, if you're living 50 meters above sea level, that's not a problem. But as we'll see in a moment, if you're living at lower sea levels, that may really be a challenge in particular. So this is something that bothers me all the time. It makes me think about Antarctica every day. Of course, in my professional life, I have to think about Antarctica every day because we're doing some work on it. But in addition to that, I keep wondering about, I look in Nature and Science and a few other journals every week to see if somebody's come up with something to do with 2 meters and how much we can expect it to be realized. And in part, it's because there are things like this going on the Antarctic that have been going on for some time, but now may have increased. So Jonathan Kingslake and colleagues published this paper in about 2017, I think, who showed that meltwater onto and across Antarctic ice shelves has been common in the past. But it's this increase and what effect it might have on the movement of ice sheets and on ice shelves themselves too, that's particularly concerning. And from a scientific perspective, the fact that sea ice has disappeared recently, it's come down, it's bounced back up, but it was coming down for several years. That may affect ice shelves. Ice shelves, in turn, if you take them away, stop buttressing the ice sheets, and the ice sheets flow faster into the ocean. And all of these processes are really quite uncertain for many areas of the Antarctic, especially East Antarctica, where it's only now starting to become clear that it's not quite as stable a big ice sheet as people thought in the past. So those uncertainties that the IPCC talks about have to do with these processes and the fact that we don't really understand what they're doing just at the moment. In addition, a piece of work that came out by Julius Garber and colleagues suggested that there's some hysteresis of the Antarctic ice sheet. And what this means in simple language is that it's easier to go in one direction and then in the opposite direction. So it's actually, once you pass a certain point with the Antarctic ice sheet, say about 400 parts per million or thereabouts, it's much, much harder going in the opposite direction to put ice back. You have to go to a completely different set of circumstances in the world. And that's the further reason why I think we need to think about Antarctica all the time. And that is because although we may slow down the change if we get on top of greenhouse gas emissions, we might not be able to stop change over the longer term. And in fact, the IPCC report makes this extremely clear in its sixth assessment report, Working Group 1. And that is that over the next 2,000 years, that global mean sea level will rise by about 2 to 3 meters, even if we limit warming to 1.5 degrees. And most people think we are probably going to struggle with 1.5 degrees in the short term. We might be able to do some work to bring it back after it's increased above that. But we are essentially now committing our world to a substantial increase in sea level and no immediate way of getting it back. There may be some technological solutions, but there are others in the science faculty that can talk more about, and of course in engineering, you can talk more about whether those make any sense or not. If we manage to get to 2 degrees warming, and of course mindful that every target between 1.5 and 2 is a target we're shooting for, then it might be up to 6 meters of change. And of course, if we go beyond that, if we go to 5 degrees of warming, because we really are profligate with greenhouse gas emissions, especially over the short term, we might see as much as 22 meters of a sea level rise. And that's unimaginable, 22 meters of sea level rise given the society we have now. And for those of you wondering about some of these forecasts, what's extremely useful is that our geology is good enough to look into the past and say what happened under past conditions when we experienced these sorts of conditions. And 125,000 years ago, when global temperatures were around 0.5 to 1.5 degree higher than than this kind of semi-pre-industrial period, sea level was 5 to 10 meters higher. So the kinds of numbers we're talking about just at the moment are certainly not outside the realm of where the planet has been before. So largely, these are the reasons why I think a lot about Antarctica. And when one talks about these matters, people say to me, well, why does it really matter? Okay, we're going to have some sea level rise. The numbers sound quite small. Even a meter doesn't sound that much. You might push a meter of water around and not be too bothered by it. And there's some research that's going on now thinking about flooding. And the first particular piece of work I'd like to draw your attention to is this work by Scott Kulp and colleagues, who were just looking at a re-evaluation of digital elevation models of our planet. So for those of you who think about how we measure how high a piece of ground is above sea level, we normally do it now by satellite. And the satellites do strange things. Of course, they read off the tops of buildings and the tops of trees and all sorts of other things. And once that was corrected for, Kulp et al. Published this indication that with the expectation of change in sea level as we see it forecast now, that by 2050, 340 million people would be under threat of annual flooding by 2050. Of course, that's not only flooding from sea level change, that has to do with river floods as well. But if you look at the numbers, they're really quite profound. So we might expect an increase to 93 million, over 29 million people in China, and similarly large numbers, especially for Southeast Asia. And from an Australian perspective, this is our backyard. We can expect this enormous change in the area that we have really most interest in and most leadership for, in a sense. We can expect huge amounts of change as a consequence of changing sea levels and changing climate in the area. And Antarctica will continue to do so, and that has a few implications for the Sustainable Development Goals. And this is really something we're thinking about. So we've made progress on clean water and sanitation. We've made a lot of progress on sustainable cities and communities over the past years. But of course, if we have this sort of thing going on, then all of that progress will be eroded immediately. So one of the things that really worries me about Antarctica is that if we see a continual change and a reduction in ice sheets and mass loss from them, which translates into sea level rise, then all of the work that we've done over the past couple of decades in improving the situation for people will be lost. In addition, of course, we have other goals in the Sustainable Development Goals. We wish to try to retain life below water and life on land. But some work that I did with a colleague of mine, Grant Duffy, has suggested that even if you use reasonably simple models, you can expect large losses to protected areas, that's national parks and similar ones, based on the more extreme sea level rise scenarios that RCP 8.5 in this particular instance. So you can expect huge proportions of loss of protected areas that are in coastal regions and any that extend down to coastal regions. And when one thinks about that, it includes protected areas like estuarine systems, which now change completely because sea level rise has forced the estuary to change significantly. And already that's becoming quite noticeable in particular parts of the world. So it's not simply our human society that's affected, but it's in fact the endeavor that we have to protect the natural world that in fact will be affected too. So all of these advances that we may think we have made stand in considerable danger of being eroded by how Antarctica and of course Greenland too behave over the next few years. And that in turn depends really on decisions that we make. In the context of the way we interact with each other, there's one last one that's really controversial that I would like to raise. And this is to do with migration and migration complexity. So migration really is often seen as an international issue, but it's also a domestic issue. So domestic migration is often unseen, but it's really politically influential. So if people move from one part of the country to the next, that of course causes disruption. And that may be small scale movement because coastal areas are inundated, but it could be larger scale movement too. And as soon as we have that kind of movement, we see eradication of progress against other goals too. Poverty, zero hunger, decent work and growth. And our colleagues at Monash who work in gender equality and violence against women and girls will tell you that these kinds of situations are not separable. So when we think Antarctica is simply this place far removed from us, we need to think again that it has an influence on our society and could have quite significantly into the future. Of course, when we think about Antarctica, as I pointed out at the beginning of today's discussion, we also think about Antarctic wildlife. And Antarctic change has an influence on that wildlife too. And some of that wildlife is truly iconic for us. So penguins are a feature of Western life. They've always featured considerably. Shackleton, for example, said that you could sell anything with a penguin. And we know that we have great appreciation for the marine life around Antarctica, and also are quite fascinated by this bleak terrestrial landscape that is Antarctica's terrestrial areas. So we do expect some change there too, as a consequence of our actions since the Industrial Revolution. And to give you a few examples, in marine systems, one of the largest changes we're seeing is changes to krill, which forms one of the most significant bases of food webs. So before the Antarctic Treaty came into force in 1959, you could find krill distributions that look a bit like this. There was a lot of krill around the island of South Georgia in the Scotia Arc, and a little less around the Western Antarctic Peninsula. By the time the Convention on Antarctic Marine Living Resources came into force, krill had started changing their distribution, and we're now starting to focus on the Western Antarctic Peninsula itself. And the situation over the last 2 decades is that really that focus has shifted almost entirely. So there have been huge southward movements in the distribution of krill, as you can see from the mean latitude, somewhere from 57.5 down to about 60 degrees. And in turn, of course, this affects all of the predators that are dependent on krill. So that's penguins, albatrosses, whales, seals. They all have hugely changing distributions. And the expectation is that those distributions will change over time. And one of the things that these conventions I've just mentioned, the Antarctic Treaty and the Conservation of Antarctic Marine Living Resources Conventions are trying to do is set up marine protected areas that will look after not only the resources themselves, but of course the seabirds and seals that feed on them. And when you look at this situation, this is a piece of work done by Mark Hindell and colleagues that I was involved in. When you use these organisms and their tracking to figure out which areas they're most focused on, and then you model that into the future, what you find is that these marine protected areas, which are indicated in orange here, these different circles here, and in the Antarctic itself, the red is marine protected areas that have been proposed, but which are not yet in force. Then you see the orange in particular indicates losses to these ecologically significant areas, and the green indicates gains, meaning that these marine protected areas are no longer going to serve the purpose entirely that they were set up for. So one of the things that we'll be faced with is very hard-won political change. Marine protected areas are extremely difficult to negotiate in an Antarctic treaty setting, are going to be lost too. So we'll erode some of those gains as well. And that's why worrying about Antarctica is important, not only for our own livelihoods on continents away from the southern one, but also for the wildlife and the iconic birds and mammals that we find are part of this region. Terrestrially, things are quite similar, and this image is very special to me. This is not the Antarctic continent itself. This is the island of South Georgia in the Scotia Arc, and it's special to me because it's the one image that managed to convert a neighbor up the road from me from being a complete climate denialist to somebody who's now completely on board with the fact that things have to change. And I was fortunate enough to travel to South Georgia in 1994 as an early career researcher, and then 20 years later on almost the same day. So these pictures were both taken in December of each of those years. And this is the Neumayer Glacier in 1994 and 20 years later. And you can see from this little peak here, and it's the same peak over there. You can see that peak again in these images here. And the Neumayer Glacier is essentially basically disappeared from this area, along with what used to be known as Gulbrandsen Lake in just a mere 20 years. It's absolutely gone. And you can actually see the initial line of the 1994, this area here, which you can make out very clearly on the image, is in fact this particular area here. So you'll see that all of this ice is indeed gone. So terrestrial areas are becoming ice-free. That changes the albedo, and of course there's a significant positive feedback effect. But in this particular region, it's just completely dramatically changed the landscape. That's not the only change we see. So this is some work by Sharon Robinson and colleagues showing that as a consequence of climate change, vegetation types are changing completely. There's quite a lot of drying in East Antarctica for various reasons, and Antarctic specialist mosses are just being replaced by globally common species. These are not invasive species. These are just species that occur everywhere, are now turning up to be much more important in these communities than the specialists. And of course, from a conservation perspective, if you replace rare species with common ones, that's not generally seen as a particularly advantageous change. In addition, and this is some work that I've done again with colleagues in biological sciences, we see there's an increase in threat from non-indigenous species that end up being introduced, usually accidentally by people. The Antarctic continent was never thought to be especially susceptible to these because it's just too horrible, it's too cold, it's too windy, it's too snowy. And now it turns out that actually there's increasing probabilities of these showing up. And in fact, quite a few have. So there's non-indigenous grasses. Annual bluegrass is the commonest on the Antarctic Peninsula. There's little midges, there are small arthropods called springtails, nematodes, all starting to colonize this area, making Antarctica look actually much more like a suburb than Antarctica itself, because some of these species are really common in suburbs. Poa annua, annual bluegrass, you can find all over Monash campus. You can find it in your lawn if you have a lawn anywhere in Melbourne. And the expectation is that we can see more of these coming. And whenever I say so, people say, okay, well, so it gets a bit of grass, what do we care? But if you think about some of these other invasive species, then the impacts are quite profound. Again, if you say it changes ecosystem functioning, some people will be really convinced, but often they're not that convinced because it's not so visible. It's not easy to see these changes. But rodents now are starting to have a particularly significant effect in the subantarctic. That's the islands that kind of sit around the polar frontal zone in the Southern Ocean. And we now know that they can have enormous effects. As climates are changing, so rodents such as rats and mice are eating away at their typical invertebrate prey, reducing them considerably and then turning to other sources. And if you don't have an especially strong stomach on this afternoon, then I would suggest you don't look at the next slide. Because it is actually quite disturbing. And this is a consequence of mice that are not normally known to do anything other than eat a few insects and be reasonably cute or just a bit annoying in other circumstances. But the effect of mice is actually quite profound on some subantarctic islands. So the mice simply eat albatross chicks alive. The chicks are naive to these animals, and the mice simply eat them alive. They start feeding either on their body cavity, around about their kidneys first, or they start feeding on their heads and eventually getting into causing significant damage to the birds themselves. So if one thinks about the impacts of introduced species, then they can be extremely profound in the region. So these are all changes that are happening there itself, and these are some of the most iconic and extraordinary birds that the world has to offer. And yet, as a consequence of this interaction between invasives and climate change, we're having enormous impacts on the area. So I'm often asked on this basis, what is it that we should do? And I think the IPCC makes it very clear. And I think we all know the answer to this question immediately, and that is that to stop some of this, to get a handle on the general change we can expect from the cryosphere and the changes to ecosystems in the Antarctic, is we simply have to stop putting out greenhouse gases. So we focus on carbon dioxide here because it's so long lived in the atmosphere. And the special report on 1.5 degrees Celsius produced by the IPCC just a little while ago makes it perfectly clear what we have to do. And that is that we have to hit net zero by 2055, but preferably by 2040 to have any chance of staying at 1.5 degrees. And it couldn't really be clearer that this is what we have to do. And how you translate that into policy or individual action is a little more difficult a question. But the fact that this has to be done is absolutely clear, and it's been abundantly clear for some time. No matter who says to you that it hasn't been clear for some time, this is not true. The modeling is all quite accurate. Even the early IPCC models, we seem to be tracking them reasonably well. So the science has been spot on all along. We're just now starting to understand the consequences and to feel them a lot more. From a research perspective, of course, what we're doing with this large Australian Research Council research initiative we were funded for is asking these very questions. What's going to happen to the cryosphere? How does that affect biodiversity in the Antarctic? What are the policies that have to be put in place to deal with this? And of course, some of these questions are so big, they cannot be dealt with by single nations alone. They require international collaboration. And in the Antarctic, that's certainly the case. There are various mechanisms of doing so. And in turn, we think in this program that it's essential for us to continue what I would call relentless communication of outcomes to domestic policy, and of course, ongoing engagement in international evidence-based policy environments. So that includes the IPCC, the Sustainable Development Goals, and the Antarctic Treaty System represented here with these icons below. And when one says relentless communication, again, in a domestic context in Australia, just at the moment, many people say, well, that's proving really quite difficult. And this is not the first time that science to policy has struggled along. And it's worth thinking to ourselves, not just that it's difficult, but what we might be able to do to change the conversation to some extent. And that brings me to the last slide that I have for you this afternoon. And it's a slide actually discussing these questions in particular. And I would like you not to pay attention to the right-hand side of that just at the moment, but to the left-hand side. And when we think about our interactions with policymakers, then we tend to have this idea that there are a couple of things that we can control and then some things that we're less able to control. So as researchers, this knowledge axis is something we know really well, and we are all trying to have more reliable knowledge. In other words, questions like what's the uncertainty in change in the Antarctic ice sheet? Can we reduce the uncertainty? Can we get those error bars a bit smaller? Can we ensure that we have very good evidence to offer policymakers? And the other axis is really what's the appetite for evidence? And of course, it could be low and it could be high. And there are various reasons for low policy appetite. It may be lack of understanding, but it also may be things like ideological vandalism or denialism or post-truth or really just commercial reasons for trying to push science out of the way. And that, I think, Naomi Oreskes' book is really good at in terms of merchants of doubt. And what we're trying to get to is this sort of area where we have evidence-based decisions, effective policy, engaged dialogue, research funding in key areas. And even if our knowledge is not reliable at the moment, we really like to try to think about how can we make decisions with wide error bars, with uncertainty. And we know that from various disciplines, this is not uncommon. It's not uncommon in economics, for example. It's not uncommon in some areas of conservation that we actually are forced to make decisions or at the very least adopt the precautionary principle. And in some settings, we're inclined to think we've ended up in this area here, this bottom right-hand box of what's essentially a 2x2 matrix, is that it's so hard to get away from this about, we just have ideology driving the way we ask questions and so on. But as mostly as people working at universities, there's one thing that I think is really important. These kinds of boxes where you essentially have a 2x2 often hide something underneath. And one of the things that this one hides particularly well that we opened was the fact that there is such a thing as knowing science or being aware of science and how science works. And that's one of our duties as university researchers, as members of civil society, is to think about what's happened in this area. And if you think about the history of society overall, and I'm speaking here about Western society and knowledge, it took a very long time for us to get to a situation where society was very keenly aware of the way science is done and the benefits of science, and we were educating ourselves to a large extent in schools and at university about how this works. What's changed is that there's been a slow erosion after some time, and there's a hysteresis here as well, in the sense that after a while we didn't really notice the erosion at first, but that erosion has actually increased quite substantially. And once you get down to this sort of area, you're on quite a fast plummet, and you can't just go back up this fast curve very easily. You have to spend quite a lot of time and energy actually getting people back up to understanding how science works, why it works, so that they have some idea that science is not magic, and that in fact is a little different to the way in which policy is effected, but the interaction is really important. And I think in a university setting, we have to do everything we can not to plunge further down this line, and to work with everyone we can, including those around you, to give some effect to this. So I always say that there's a lot of people that feel a lack of agency at the moment. They feel they're completely overwhelmed by the system or what they have to do. But of course, as individuals, we can do a huge amount to stem this as those working in a university setting. So overall, I'd just like to end by saying that Antarctica is extremely important, and how we talk about Antarctica is extremely important, and how we talk with each other about this is important too. And I've benefited from many conversations with the colleagues listed here and from several others. And I just want to acknowledge the sources that quite a few of the images and quite a bit of the work was drawn from. And of course, the illustrator who's done quite a lot of work with me, Elizabeth Botti, who's provided the illustrations you've seen. And with that, thank you, Perrin. I'm happy to take a few questions. I have to acknowledge our funders, of course, the Australian Research Council and of course, the Australian Antarctic Program, and Monash for all the support. But I think I'll leave it there for this afternoon. Thank you, Perrin, and thanks to all of you.
Thank you very much, Stephen, for that fascinating and thought-provoking talk. I think you have another meeting at 2:30, so maybe that gives us about 10 minutes for questions and discussions, if that's all right, Stephen.
Yeah, that's perfect. Thank you.
So does anyone, I'll throw it open to the floor. I think we'll try, just if you have a question for Stephen, perhaps unmute yourself and feel free to ask the question.
Stephen, just a quick question about public attitude and how we can turn things around. I really pay close attention to the last slide and that descent into a scientific dark age, if you like, and that's being driven also by a sense of frustration and helplessness about what's happening in the world around us. How do we actually turn it around? Is it really just a matter of starting local?
Of course, if we were able to turn it around quickly, and somebody knew the answer to that, I think we would have already done so. But my experience is that you are best served by talking across as a broader range as possible. And again, although it takes quite a lot of patience, I have to say, is to try to understand what is it that if there's somebody in the policy area that really doesn't want to take on board some evidence you're presenting them, is to try to understand why that is to begin with, and to listen to them first, is to actually have a good listen to them rather than having a straight up disagreement. So and that has worked for me anyway, both in an international policy setting. And I'll give you an example. When we first introduced the question of invasive alien species about the Antarctic, a member of an international Antarctic program, not here, but from abroad, from Europe, said to me, "Oh, what do you think we should do? Wash our ships, lift them out of the water and wash them all down?" And the answer to that was actually yes. When you dry dock them, you could give them a good clean out, it would be quite helpful. And that started a conversation that went on for years because I spent some time trying to figure out what it is that they do and how they operate with their ships. And I would say that the more you can listen to people then, and then try to speak to them in areas that they appreciate, the better the opportunity is. Having said that, I also think that there is, for your own sake, worth realizing something that I think Jonathan Swift, the author, first said, and was then resaid by several people, but best by Daniel Dennett, the philosopher. And that is, you can't reason someone out of a position they didn't reason themselves into in the first place. So if you encounter really just complete ideology and lack of reason, often it's not worth pursuing it. It's simply worth putting a check mark against it and saying that it's too difficult. Is there some other person you can talk to in the same place? And in international policy delegations, often what I've done is stop talking to that person and try to find somebody else in their delegation who's more approachable. Because if you just have a hard wall that you're bashing your head against, then there's no point in trying to continue. But I also have to say that in some of the things that we managed to get done, it took us about 10 years of talking. Now that's quite short, too long for net zero, for example. We're supposed to get to at least halfway by 2030, and that means that there's 9 years left. So in part, I think that the time for what some scientists would avoid, which is strong advocacy, is upon us. I think if we don't all participate in stronger advocacy than we might have been inclined to previously, then we're not actually going to meet this target. And that advocacy is local. And for example, writing to your MP, I encourage lots of people to do this. You have an MP, write to the MP and say to the MP that you're just really not happy with the way things are going. And it's going to produce hardship for everybody in the place that you live, whether it's really, and whether it's your local representative too in state parliament. Write to them and make them think about it. I've had a very interesting and ongoing discussion with our local one in the Knox area, where I took great umbrage at some of the things the person was writing in their kind of weekly mail to their whole mailing list. And I said, this is complete nonsense. And here's all the evidence, and sent them all the research papers and said, I'm happy to have a conversation though. I don't mean to say how you should run your policy, but I think that the evidence you're being presented with is incorrect, and I'm happy to have a conversation. And we now have a great email discussion on the go, and I'm not sure it will have any effect, but at least we're having that conversation.
Thanks, Stephen. I think that's extremely good advice. So we've got a question from Ruth. Ruth, maybe if you unmute yourself.
Yeah, so I noticed on your 2x2 plot there, you had one of the things that moved items between boxes was economical. And I was wondering, I mean, like I've noticed, especially with my colleagues in environmental science, there's a big push to value economically ecosystem services or the loss of an ecosystem. And I mean, like I review papers like that every week, and it's, I feel like personally, I'm not sure that's the approach here, but I was wondering what you think how the valuation of these, you know, the cost of flooding or the cost of is improving how science is received by policymakers, or is it just a completely different conversation?
Thanks, Ruth. You know, the kind of natural capital evaluations and so on that go on often, it's not my field of speciality, but I tend to do a few things. I think that when you're talking with economists, it's worth saying to them, yes, there are ways to do this. There are ways to put a price on things. And once they start talking about that, then I say to them, you can price things. You can price almost any commodity you want. And sometimes it's priced very low. Carbon, for example, varies in price from a lot of places. I think carbon should be priced much more highly since we have so little time left to keep it in the ground, for example. And that often I just get lost because they come up with economic theory and pricing and all sorts of things, and I'm gone, you know, it's not my area. But the way I like to try to change that conversation and say that I think pricing and value are things that we should just change a little bit. So putting a price on something is very different to putting a value on something. And you can call it whatever you like, but we may value things well beyond any price you could put on them. I think the other day I read a piece that was by Neil Ferguson, the commentator from the UK, about he has a book called Doom, which is on pandemics, and he said that actuaries value a whole human life in the UK at about 3 million US dollars. That's the value of a life. But that's, he pointed out, that's the price of a life. You wouldn't put a $3 million tag on anybody. It's just completely crazy. And that for me really set the tone of how to differentiate this conversation. So in some settings, it is worth finding out what the price is of something and how you would do that. But it is also worth, I think, in those conversations saying some of these things are not renewable. Ecosystems are not infinitely renewable. There are threshold effects, and economists don't know that. They often forget hysteresis and all those sorts of things where you say, if you remove it, it's never going to come back. If you flip the system, it won't come back. So you can't just put a dollar value on, say, I don't know, removing all the trees out of the alpine area of Australia. You might not get it back. It might flip to a grassland, and you're never ever going to get it back. So that's what I would advise under those circumstances. Although I have to say I lose those arguments quite often. So.
Okay, thanks, Ruth. I'm conscious of time, but I think we have time for one more question, if that's all right, Stephen.
Yeah, sure.
So feel free to unmute yourself. Okay, so I might use chair's prerogative. And hopefully this isn't too naive, Stephen. I'm sort of now digging down into specifically Antarctica in your area of expertise. So obviously there's a lot of change going to happen in Antarctica in terms of the ecosystems down there, particularly on the Antarctic Peninsula as the ice melts. And I presume that SAEF will be looking into this a bit, but how do you see, so obviously there's going to be a lot of ecosystem change down there. Do you advocate, or do you think you will advocate just humans being observers of those ecosystems as they change, or do you think there might be roles for interventions in terms of getting desired outcomes to preserve particular aspects of those ecosystems?
Perrin, there's certainly a role for action, and it's kind of a question that's asked in the Antarctic Treaty itself, not the marine section, but in fact the treaty itself that's often concerned mostly with terrestrial areas, is what can they do? What role do those policymakers have? The Antarctic Treaty consultative parties are responsible essentially for the governance of Antarctica and for its environmental conservation. And there are local actions that can be taken to ensure that the values of the area are preserved. And some of those are reasonably straightforward and easy to do, and some of those are not so easy to do, are quite unpalatable. So, for example, suggesting that there should be increased biosecurity measures to stop things coming in that would establish more easily is quite palatable, and it's quite widely adopted by the Antarctic Treaty consultative parties and the industry body. It's mostly the tourist industry body, of course. Tourism is big business in the Antarctic. It was up at about 60,000 people who visited just before the pandemic year. And they're quite keen on that as well. And that's fairly straightforward and palatable, a change to make. But if you start suggesting things like sharing stations or reducing the number of stations and not having as large a footprint of stations, that becomes less palatable and a much more difficult argument to make. But again, there's good reason to suggest that that shouldn't be done. And the regulators are very keen on looking across at industry like tourism, and a little less keen on looking at themselves. And but one has to continue, and I think one has to say to them that you have to realize that it's all human intervention that's important in that area, and that it has to be a local interventions to give some security, and then you're going to have to walk across the corridor in whatever department you're in, Foreign Affairs and Trade, or if it's the Foreign Commonwealth and Development Office in the UK, and say to your colleagues who's going to COP26, you have to actually get this done, that this is essential. If you don't get it done, you don't have to bother coming as a tourist to Antarctica. It'll come to you. It'll wash up on your doorstep. And it'll do so reasonably quickly if we're not careful about this.
All right, thank you very much for that, Stephen. All right, so I'm conscious of time. Thank you very much for that fantastic presentation, Stephen, and for being our first speaker. If everyone could show their appreciation for Stephen, however one does on Zoom, I will physically clap. Thank you very much for that. So just a few things before we move on. So next month's speaker is Professor Christian Jakob. He's an atmospheric scientist. So that'll give us another perspective on the climate system and the changes that we're bringing to the world. As you may have seen from an email from the faculty, there are 4 posters that are being presented by postgraduates and early career researchers in the faculty. So 2 of them are from the area of energy and low CO2 emission solutions, and 2 of them are around one of them is around CO2 emissions and another is around sea level rise. So we're going to go out into 4 breakout rooms, and so you can then engage with the presenters in those breakout rooms. Once you're done, then that's the end of it. And just before we go, I'd just like to have a big thank you to the faculty for supporting this, in particular the Associate Dean for Research, Jessica Purcell, and also thank you very much to the people who helped me organise that, particularly Anna Stender and Sylvia Dropulich for all the fantastic advertising work. So there's a chance, hopefully we'll see each other face to face next time. But if not, we'll be back on this same medium in about a month's time to hear from Christian. I look forward very much to seeing you all then. And hopefully I'll see a few of you in the breakout rooms now. So Anna, hopefully you can create those rooms and we can just then enter the rooms as we please to
They're all
talk
open.
about. They're all open. Thank you very much, Anna.